This Week in Virology, the podcast about viruses, the kind that make you sick. This Week in Virology, episode number 278, recorded on March 28th, 2014. Hey everybody, I'm Vincent Racaniello, and you are listening to TWiV, the podcast all about viruses. Joining me today right here in the TWiV studio, Dickson Despommier.
Hello, Vincent.
How are you, Dickson?
Very well, thanks.
I've seen a lot of you lately.
Yeah, you might be getting tired of me now. We're twipping and twiving and urban egging and all this stuff.
Something else, huh?
All kinds of stuff.
I'm
We're having a good
not tired
time, though. I thought we were having a good time. You do a good job of faking that.
Thank you, Dickson. It's good to have you back. This is actually the first time we're recording here in studio for a couple of weeks. We've had a weird on-the-road thing going.
Exactly.
Also joining us today from Ann Arbor, Michigan, Kathy Spindler.
Hi, everybody.
How are you doing?
Good. It's good to be back with you guys.
Yeah, it's been a while. It's weird. Things happen, but yeah, I enjoy doing these all together. Mm-hmm. How's the weather out there in Ann Arbor land?
It's kind of gray and 40 Fahrenheit, 4 Celsius.
Right.
It's going to be warmer by Sunday, though, and sunny.
Uh-huh.
So
looks like winter is leaving us.
There's a New York Yiddish expression for this weather pattern. It's called meh.
Meh. Meh.
How's the weather outside?
Meh.
Meh.
Also joining us today from Western Massachusetts, Alan Dove.
Meh.
Hey, you too, huh?
Yeah.
There's no
49
sunny days
Fahrenheit,
today.
9 Celsius.
Yeah, it's meh.
Drizzly, wet, cold.
Exactly. It's spring.
Yeah.
It's spring.
Springtime in New England.
Tell me all about it.
Or mud season, as we refer to it.
That's right.
You know, in some places, there's still piles of snow left.
My front yard.
The end of my driveway. Yeah.
Especially in a parking lot the other day. Huge piles of snow, and they were all black.
Right.
Mm-hmm.
It's so unattractive.
So what's the tallest mountain in the British Isles called?
Is it a landfill?
No, it's called Mount Snowdon. But I think you've got them beat on this one. Mount Snowplow was a much better name, I thought.
Mount Snowplow.
That's right.
Mm. All right, so here we are on a rainy, gray day. Back to TWiV in studio. We have a couple of follow-ups. The first is from Robin, who writes, "Why haven't they contacted us?" So in last week's episode, I asked towards the end about whether there was life elsewhere, and we got into a little discussion, and we said, so one of us said, why haven't they contacted us? So he sent us an article on the Fermi paradox, which is exactly that problem. It's likely that there is life, given all the billions.
Yeah.
But why haven't they contacted us?
They're all mute.
There are lots of possible explanations, but we don't know the answer.
No.
Well, the possibility I like is, we've been transmitting radio signals ever since we developed radio, and probably, the original television broadcasts are now reaching the various places in the galaxy, and they're looking at it and saying,
we don't want to
we don't want to talk to these people.
Forget about it. Are you kidding?
Yeah, I like that one. That's good too.
Yeah. They use hand signals. That's how they communicate, so we can't really hear them speak.
I have a follow-up from Stephen, who writes, Dear Twivers, first, I wanted to say that despite Vincent's dire warnings of doom and gloom, the most recent podcast on his background was fascinating. I only wish the other regular hosts could have been there so I could have heard their reactions. They would have been snoring.
No.
Yep. I didn't want to really do it. He had to twist my arm. Anyway, he also writes, the Etsy store Waddy's wall stuff recently came to my attention. It includes many cross-stitched microbes.
Huh.
In addition to selling completed items, she has kits and patterns for anyone who wants to make their own T4 phage or anything else in her collection. Thanks for all the great work. And John also sent a link to a different site, but with the same cross-stitched microbes. These are really beautiful.
Oh, nice.
They are so neat.
And
A lot of synthetic biology going on.
They're beautiful, little delicate bacteria and cells. They even have parasites, Dickson.
Yes. You might say these are microbial networks.
Ooh.
They have nice T4 bacteriophage.
Cool.
green tail fibers and red shaft and head.
Yeah.
Huh.
Now, Kathy, what would you do with these?
Oh,
Yes.
you'd put them up on your wall in little, like there's a arrangement of 4 of them or something like that.
She shows them all with the frame, but you don't get the frame with it, right?
I think you probably do
Yeah.
with these.
So
Yeah.
you'd hang it on the wall in the frame. It'd be kind of like showing how it was made. Oh, that's
Yeah.
nice.
It's it's not all just cross stitch. It's counted cross stitch, and other needlework methods.
She shows
Now that I'm looking at
exflagellation and
photos.
malaria. That's very nice.
You're looking at them, Dickson?
Oh, sure.
They have sporozoites,
Oh, yeah.
gangrene, tuberculosis, smallpox.
Who could not like this?
I mean, they're so delicate. That's what I like.
Yeah.
They are.
Yeah.
I
Yeah.
like the aspergillus. The little spores coming off the hyphae.
Sure.
Very pretty, Alicia. So we will
Yeah.
give you the TWiV bump. They'll be sold out by Monday.
Right.
Yep.
And on the bottom of that page, it says you might also like, and then it's got this huge collection of embroidered tamari spheres. So I went to that page, and then there's a Flickr page of these tamari spheres, and they're beautiful.
Wait, this is by someone else?
It's by someone else. So go down
Which
to the
page?
bottom of the cross stitch page, and you see the tamari spheres link. It's a blue and white thing, and then and it describes. Where does it describe it? Right up at the top? No, toward the bottom. Tamari balls are a form of folk art originating in China, introduced in Japan in the 7th century. Carefully hand-embroidered balls, often made from the thread of old kimonos, were created by parents or grandparents and given to children on New Year's Day. They would sometimes contain secret handwritten wish for the child or some kind of noise-making object like a bell. And they're beautiful. So, and I mean, they look reminiscent of some really big viruses. You know, they're spherical, so they're cool. Some of them.
This is cool. She says, if you want something less germy, here is a set of gametes. She's got a sperm and an ovum.
Right.
Neat. Well, that's really beautiful.
Yeah.
Really
Yeah.
gorgeous. Thank you, Stephen and John. Those will be part of our picks of the week. You have some news, Kathy, from Ann Arbor?
Well, first I was going to, be in reference to
right.
the interview of you, I would have asked, and in part because I had just heard some other thing on the radio, I would have asked, how did your parents adjust to the fact that you didn't get into medical school, you then became a lab tech, and then you eventually went to graduate school and became a professor? So.
Well, that's an interesting question. So they didn't say very much. You know, I remember going home after graduating, and they didn't really say very much. So I kind of took things into my own hands. And then I remember as a postdoc, I was home once, and I had been preparing my taxes. And as a postdoc, I got paid $12,000 a year.
That's right.
It was in 1980s.
So the biggies.
And my father looked at it, and he showed me his tax return, a couple of orders of magnitude bigger. And
Add a couple of zeros.
I think he was saying, basically, this is what you gave up, you know. And then many years later, when I was here in my lab, so at that time he had terminal cancer, and he came to visit with my mother, and I showed him the lab. I brought him to the animal facility. I explained stuff.
Right.
And then he said, well, I'm really happy that you finally found something you like and you're good at. So at that point, it seemed like he was okay. Right?
Oh, that's good.
So before he died, he saw his son was all right. So that's good, because you like to have a little resolution of that.
Right.
But I didn't hear for many years. I don't know. I think I have this retrospective view that we weren't a very talkative family, but it may be wrong because I just don't remember. But, so in the end, he was okay, right?
Yeah.
But if I had done something like...
Dentistry.
Well, no. I mean, if I were doing things that weren't very creative or interesting, or I couldn't support myself, he wouldn't be very happy. But the kind of guy he was, he would never say, you shouldn't be doing that or this. He's kind of, the silent treatment type.
Right.
And your mom?
I talked much more with her, yeah, for sure. And I think she's the one who relayed that your dad is very content that you found something. I guess she was too. I don't know. I figure I would guess she would feel, this is my kid. He can do whatever he wants, and I'll be happy. She was that kind of person.
As long as it's legal.
Yeah. That's a long time ago. It's all gone. It's going to be forgotten. But that's cool. Yeah, that's a good question. And I think that's, you have to support your kids, right? You have to say you're doing good stuff and
absolutely right.
give them encouragement, because there's plenty of criticism in the world.
Yeah, there's enough outside.
Oh, yeah.
But it goes on inside the family, too. There's no question about it.
Okay. All right. So what else we have? You have one more thing there you want to talk about.
Oh, right. I just wanted to mention that while we were all away from TWiV, you weren't, but we got the news that John Masab, his first name was really Hunain, but once he moved to the United States, I think it was in the 40s, he went by John, passed away February 1st. And so was an obituary in the New York Times. And as you know, he was the developer of the cold-adapted flu virus that went into making the flu mist vaccine. So he was really persistent. The obituary talks about that. He was really bound and determined to see this make it into a usable vaccine, and he got to see that. So
I never met him, but when I was in Peter Palazzi's lab in the 70s, we got his cold-adapted viruses, right?
Mm-hmm.
And I have my lab notebook here. Dickson, you're seeing me do this.
Yeah,
so this is
a witness.
This is like a paper
Wow.
thing, a little hand. I used to put all my protocols here, and I have items in the -70 here, and I have all my viruses. And here I have cold-adapted variants, AA/2/67 and AA/1/70. And these are the viruses that eventually went into flu mist.
Darn.
And I remember Peter Palazzi saying, here, look at these. These will never amount to anything, but you can do something with them. And then, what did it take, 40 years for them to...
Well.
So, the story was that the company that originally developed flu mist, what was it, Aviron, I think, who was later acquired by MedImmune. So Palazzi and Greenberg and Reutemann all founded that company. The idea was they were going to construct, by genetic engineering, a cold-adapted flu vaccine. And they basically ended up licensing these viruses from Masab. And that's it. Really interesting, because they couldn't do it. But he had already done it.
Yeah.
Isn't that cool? I have that in my notebook.
That is cool.
Vincent,
So, and the AA in the name of the viruses is, of course, Ann Arbor.
Ann Arbor, because they were isolated. I think they were isolates from Ann Arbor that he modified, right? Mm-hmm. It's very cool.
Nice.
Too bad we didn't talk to him on TWiV, right?
I didn't ever get to meet him here at Michigan. So
he had retired before you came there?
Yeah, and he was pretty ill even about the time that the FDA licensing happened, because Rosemary Rochford went to the licensing hearing or whatever in his stead. So, yeah.
All right, we have one paper today. I thought we would do one because we have a bunch of email. When we do these on-the-road TWiVs, we don't really do much email.
Build up the email.
And so let's do that. This one is actually a follow-up to a TWiV that we did a while ago, which Alan Dove entitled HIV Gets the Zinc Finger. And people love that title. And it's in that paper which we discussed, they use. So the idea is that can you engineer cells to be resistant to HIV infection? And we know that there are people in the world that have a deletion in the gene encoding one of the two co-receptors for HIV. So when HIV infects cells, it needs to bind to CD4 and a chemokine receptor, which can be either CCR5 or CXCR4. And about somewhere between 4 and 16% of people of European descent have a mutation in the CCR5 gene, and they don't make the protein, and they're fine, and they have resistance to HIV. If they are heterozygous for this mutation, they are somewhat resistant. And if they're homozygous, they're completely resistant to infection. And our listeners may remember the German AIDS patient a number of years ago, a man with AIDS who was given a bone marrow transplant from a donor with the CCR5 deletion.
Mm-hmm. Right.
So in this procedure, you irradiate your bone marrow to destroy all the cells that give rise to your immune cells, and then it's replaced with the donor cells. And in this case, this man now has all CCR5 negative lymphocytes, and he's virus-free for a number of years now.
Nice.
They destroyed his immune system in order to save it.
Indeed.
And, of course, bone marrow transplant is way too expensive and risky to be a therapy for AIDS.
Yeah.
It's like 30% fatality rate.
It's funny. A student from Kathy Collins' lab was giving his student seminar today, and one of the faculty members asked him afterward about, well, what about transplantation, bone marrow transplantation? He said, oh, you want me to talk about the Berlin patient?
Yeah.
And basically the student said, well, and do you want to go with the clinician to get the permission from the patient to do the whole body irradiation and the transplant? Yeah, risky.
But it makes a proof of concept that if you could somehow modify CCR5 gene, you might make people resistant to infection. So the paper we did on TWiV a while ago was taking out lymphocytes from people and culturing them, and then putting in them what is called a zinc finger nuclease, which is a protein that can be engineered to target a specific sequence and make a double-stranded DNA break at that sequence, which is then repaired. And when the cell repairs it, it often makes a mistake so that you mess up the reading frame of the gene. And so in that paper, we showed that we discussed how these cells acquire some resistance to HIV. Now, in this paper, they have done that again, but in this time they put it back into the people. And I have to tell you, this is just, I got chills reading this paper because it's 12 patients that they enrolled. These are all AIDS patients. And half of them, they're all on antiretroviral triple therapy. And half of them had good CD4 T cell levels, the other half not so good. But they all had low virus loads because of being on antiretrovirals. And they did a lot with these patients. I mean, they start by taking 10 liters. They did a 10-liter leukapheresis where they basically hook you up and keep filtering out your blood until they get the amount of cells, 10 liters worth of filtering, and to get the CD4 lymphocytes. And they have to purify them in ways and put them in culture. And we'll talk about that. But then they put them back in them, and they do all these. They almost for 250 days they follow these patients, and they do blood sampling. They do some rectal biopsies to look at mucosal invasion of the cells. I mean, these, in a journal article, it just looks like numbers, but these are people who have volunteered to do this, and they're being totally invaded. And I can imagine if I did this, I would feel like a subject, right? With no humanity. I wonder if they have in these clinical studies some therapists who talk to people and say, you are a human being, we realize. Because I would think it would be tough.
A lot of these people get very altruistic because they've seen other people in the past suffer greatly from this infection without the advantage of triple therapy, and they don't want that to happen again. So they're very heroic people.
I'm amazed at the extent to which.
And bear in mind, these are the clinical trial is taking place in a hospital and a good hospital at that.
Of course.
So as these patients are going for their rectal biopsy or whatever other invasive procedure, or this 10-liter hooked up to a machine, the people around them understand that they're in this clinical trial and are hopefully treating them fairly nicely.
Yeah, of course. But it's just when you read it, you realize that there's a lot of room for. You have to appreciate what they go through. It's not just the numbers on a page.
I mean, some random contamination of a catheter or a tube that
you have to be so careful.
Inside.
I mean, this is a huge thing. You have to have a protocol that's approved, and there are rules about what to do if things happen during the protocol, and you can't. If you violate them, you're in big trouble.
Right.
This is why clinical trials are such a huge deal, and why they cost so much. Is that as soon as you start working with people, even in a what we would consider a very tiny study like this, you've got a dozen patients, but that's, those are a dozen people's lives.
Yep. Absolutely.
Sure.
And this goes to show that ferrets are not humans. Because you don't have to do this to
This is all
ferrets.
true.
That's right.
So the 12 subjects, they do this 10-liter purification for lymphocytes. Then they basically want to purify the CD4 positive T cells. These are coming from the blood. They do some purifications to enrich them and put them in culture. And then they introduce the zinc finger nuclease, which is basically the zinc finger coding region, which has been constructed so that it can target the CCR5 gene. And we talked a lot about this on that previous TWiV. So if you want to know the details, I think that you could go back to that. But basically, the zinc finger will target the CCR5 gene specifically because it's going to recognize that sequence. And it's delivered in an adenovirus vector. So this is a replication-deficient adenovirus. So it delivers the gene to the cells, modifies the CCR5 gene, and then they take those cells and put them back into the patients. And, of course, they can check and see how much of the gene has been modified. And they say about 25% of the cells end up having a modified CCR5 gene. And that's important because at some point in the future, you want 100%.
Absolutely.
Right? Because then it will be more efficient. So they put these back into patients. The object of this study was really to look at the safety of this procedure, but then they did, of course, measure a lot of other things at the same time, and that's the basis for the paper. And there's just a rich number of figures here. So first they look at, so these are put back into people, they're infused into people, and everybody was okay with one exception. Somebody had an adverse event which had to do with infusion of the drug. So then they continued with everybody. And they looked basically, they sampled these individuals, again, over 250 days. They looked at total lymphocytes, and they could break that down into CD4 and CD8 cells. And then they could also see which of these lymphocytes were the ones that they had put in, as opposed to the ones that the patients already had with unmodified CCR5. So you can see in one of the figures that, right after the infusion, the number of total lymphocytes goes way up, as does the CD4 T cells.
Because you put them in.
Because you put them in. Then they start to go down, and I guess they're just kind of reaching homeostasis, right? Because you put a lot in, and then they turn over, and then they go down. And these are mainly CD4 cells, as you would expect, because that's what they put in. The CD8 counts don't really change. And they have data for each individual patient. These people are, as I said earlier, divided into two cohorts, one who had good CD4 cells after their drug treatment, and then the second, which had lower CD4 cells. And you can see...
I thought it was before they started, were the baseline CD4 T cell counts.
Yeah, I think 0 is the baseline, right? So we know that before the infusion, you mean, right?
Right. So there was a cohort that had baseline ranging from 500 to almost 1,000.
Right. The cohorts were divided before the infusion, right?
Right.
This because for some reason, even though they're all on antiretrovirals, some had good levels of CD4 and others had 600 to 900, and then the others had between 190 and 300 cells per cc.
Right, which I think is why they normalized, like figure 1, they normalized to the change in CD4 T cell count from baseline. So everybody starts out at baseline 0, and then they plot the change, so that they can put these two different cohorts on there.
So you can look at the change in as Alan had said, you could look at the ratio of CD4 to CD8.
Right.
And then so it turns out, and I guess I knew this but didn't appreciate it, that most of your lymphocytes are actually not in your blood, but they're in lymphoid organs like lymph nodes and spleen and the wall of your Peyer's patches, right?
50%, I think, was the number, right?
Yeah.
50% are in the mucosa.
Yeah. So when you sample the blood, you're not necessarily getting
an
indication of what's in the mucosa. So, I mean, the best they could do, I guess, was do a rectal biopsy and pull out a little Peyer's patch and check what's in there, and that's what is looked at in the next figure. They compare the circulating versus mucosal, and now they're looking at the CCR5 modified. So this shows that, in fact, in the circulation you have CCR5 modified CD4 cells, and also in the mucosa. And again, it goes up right after infusion, and then goes down and reaches a certain level. So these cells are injected into the bloodstream, but they do make it into the lymphoid tissues, at least into the mucosa and the intestine.
It'd be interesting to see if they had the same distribution afterwards as the normal population of cells before they did that, or whether there's some bias with regards to this particular modification.
They did have an untreated cohort here. Probably that information is here. but I can't tell you it. Mm-hmm. Now, they did an interesting thing with these, with one of the cohorts. After 28 days, they stopped their antiretroviral treatment. Now, that's really something, right?
Yeah.
Because this is what
That's yet another leap of faith.
is keeping them somewhat healthy.
That's right.
And so one cohort, they stopped from 28 to 112 days.
Goodness.
So, and the idea here, of course, is there's not much virus in them, so you would like them to have some virus so you can see what happens to these cells if they're resistant to infection or not.
Right.
And we're reminded again that these are people who,
yeah, absolutely,
who've signed up for this.
They all consent, absolutely.
Yeah, they're going to stop taking these drugs that they know are keeping them alive.
This is not Henrietta Lacks era. This is a new time where you got to consent to everything.
And this is a truly altruistic thing to do for patients in an industrialized country who have access to retroviral therapy.
Yeah.
And then this is where those criteria come in again, because of those 6 patients, one of them had 3 consecutive viral RNA levels that were over 100,000 copies per ml, and that was a defined stopping rule.
Right. So give you your drugs back, absolutely.
So they put that patient back on.
Yeah. Mm-hmm.
Then another patient's primary care provider was concerned about the rapid increase in viral load, and so
which is understandable.
Yeah. So they ended up having 4 patients that completed this treatment interruption. So
they measure the viral load, as Kathy has said, by polymerase chain reaction, and this is viral load in the blood. And of course, after they interrupt treatment, the viral loads go up. It's different for every patient. They have all the individual patient numbers here on the graph, and you can see some are very different from others. The kinetics are quite different. But I guess one thing I noticed, and tell me if this is the right observation, the viral loads all start to decline before the drug treatment is restored.
Yes.
Is that correct?
I mean, it looks that way in the graph. Yeah.
I mean,
and you attribute this to the modification of the lymphocytes.
That's what I would guess, because now you're sort of enriching. So these viruses are coming out of latently infected cells, and they're infecting CD4s with CCR5 on them.
Right.
Yeah.
And my guess would be those are being destroyed, but the cells that were infused are now resistant, and they're proliferating, and so you're getting less and less virus. That would be my guess, although I don't think they ever made that conclusion in this paper.
Yeah. On the other hand, when you look at the graph right below that of CD4 counts, they look at the CCR5 modified CD4s and the regular CD4s.
Right.
And you don't see the CCR5 CD4s taking over.
They do not take over. Right, but the unmodified CD4s are clearly going down.
They are clearly tanking, and the CCR5 modified ones are clearly not. They're staying level.
There's they peak a little bit at the infusion, and then they go down to a set point, and then they stay there. Right.
Yeah.
The unmodified CD4s, they go way up after infusion, right? And then they start to go down before treatment interruption. I don't know why they went up after infusion.
That's a good question.
Maybe these are the unmodified ones in the pool that were injected, right? Because not all the cells were modified by the zinc finger nuclease.
Yeah. Right. Yes. Because I guess and that would represent the efficiency of the
targeting
modification.
So you can't get them all. So you can't distinguish them. So that may be that. So then the endogenous CD4s, as soon as you interrupt the drug treatment, they go way down.
Yeah.
But you see in that second graph, it's figure 3b, the virus peaks at, midway through the treatment interruption. Then it starts to go down, but there's still no drug there. So that's why I would guess maybe that's because of the...
it's running out of susceptible cells to infect.
How many replication cycles do the infused cells go through, do you think?
I think a lot. Probably a 24-hour dividing, right? More or less, like most cells.
And that study was done over a long period of time.
250 days. Oh, these cells are definitely dividing, sure. I mean, they're made to...
They have the gene-modified T cells could be detected in a long-term follow-up study, the longest to date being up to 42 months.
Wow.
Yeah, they engrafted, as one would say, right? They're there.
Yeah.
So, I mean, eventually, does it have the hope, of course, of being the sole survivors, basically, of this regimen? So they will be totally resistant in 3 or 4 years.
No, they won't be totally. These are not homozygous modified cells.
Okay.
So I think there's a figure in the
That's fair enough.
supplementary data which shows that they're not. You don't get both copies of the gene modified by the zinc finger treatment.
I forgot that.
I don't know why that would be, but I guess it's a hit kinetics thing, I suppose.
Right.
But yeah, you need to work on getting both alleles knocked out. That's for sure. That would really help because these cells won't be totally resistant. They'll be resistant, but
Got it.
not fully. So you could never. I don't know if you could ever get rid of virus. Maybe that combined with antiretrovirals, if they keep the viral load low enough, it might. I just don't know.
Well, an important thing to remember at this point is it was not the point of this clinical trial to prove efficacy.
Right.
So, which you couldn't do with 12 patients anyway. This is what we would call a phase 1. So this is a trial to see if this is safe.
Right.
And that's why they're tracking CD4 counts, but the treatment interruption was that would be part of what you would hope to do in the long run. So you want to make sure that after you do this autologous there's reinfusion, if you then interrupt treatment, you're not going to cause some horrific problem. So all these little signs that maybe it's working,
yes, they're just signs,
maybe it is, but you'd need to do that in a more systematic manner.
And then the last figure is basically, again, looking at the modified cells during the treatment interruption. You can see that the modified CD4 is pretty much, there's a little bit of a decline during the treatment interruption, but not as much as the unmodified CD4 cells. And again, it's very variable from patient to patient, right?
Yeah.
As you might imagine.
Of course, it's all over the place. There's one patient who's very interesting here who, after taking this patient off, this is number 205, after taking this patient off of the antiretrovirals, it took quite a while for the virus to start replicating. It turns out that patient had the CCR5 mutation. What is the chance of that?
Oh,
they were heterozygous for
CCR5.
mutation.
Isn't that amazing?
Yeah.
I guess they didn't look because they figured it's so rare, right?
Right.
Yeah.
And but that person controlled really well because of that. So that would say that if you could figure out a way to knock out all of these, both CCR5 genes and lymphocytes, it might really help. Now, so I asked some T-cell people about this, and I said, what are the limitations? And they said, well, the problem is you're taking peripheral T-cells, and they're not the whole repertoire that you have. So even if these multiply, they would be oligoclonal, basically, not as diversified as your normal T cells would be. And so you wouldn't have the same defense against other infections, right? Because all the T cells you have are there to recognize foreign antigens, and this is just a subset of those.
Right.
So that could be problematic. And he said also T cells eventually get exhausted. They don't divide forever. They will divide but you're always making new ones from the precursors, bone marrow, and they won't divide forever. They'll get exhausted.
Sure.
And so this could be a problem long term. So maybe it's not the solution. But it's pretty neat.
Yeah. And it suggests that this is not a bad line of thinking. Maybe this is probably not in its current state a viable treatment mechanism. I mean, this whole thing with getting out this many of the T cells and putting them back in and all this, you're not going to do that with everybody who walks into a clinic. But this illustrates that, we may be getting at the crux of a method that would work if we can get CCR5 turned off in the T cells. Maybe we've got something.
Certainly would be a lot easier if you could give individuals a virus that would modify
both
CCR5 in them without having to infuse them.
That's right.
And of course, maybe you could use CD4 to deliver that virus, although CD4 is on other cells. Well, I guess it wouldn't matter if you modified CCR5 and all, because these individuals with the deletion are okay.
Yeah.
I think that's amazing. In virology, I always say, receptors are there for the cell, not for the virus. So it's not easy to think about modifying the receptor genes. But here's an exception.
Yeah.
So none of the cells ever get both of them knocked out? Ever?
I don't know. I don't think none is. I think a fraction do.
So
they
what
say
if
that
you
in
did
the,
one round of treatment, which blocked the one of the pair, and then had some way of identifying the one that's affected, and put another block on it to prevent the next round of treatment from finding that one, and it only had a choice of the one that didn't get blocked the first time.
So you just say multiple infusions?
Yeah, two
No,
rounds.
I think that's hard, Dickson.
If it's a complete cure.
33% of the cells that got modified underwent biallelic modification.
Biallelic.
Does that mean both alleles?
It sounds like it. Sounds like it.
So 33% of all the transduced cells, which is
A third.
Okay, but yeah, you want more.
You do.
That's what they say also in the paper. I assume that would be better to have more.
Of course.
Although those biallelically modified ones, of course, are going to preferentially proliferate. They'll be resistant.
That's right.
But again, they're going to be a subset of the T
now
cells.
you're cloning your
the
clonal
T-cell
selecting
repertoire,
for the
yeah.
cloning
Exactly.
repertoire. You've
Yeah.
got a reduced repertoire.
Yeah,
that's
that's
not
right.
good either. That's not good. No, not good. Not good. In fact, could you actually get all the T-cell repertoires just from peripheral blood?
No, I don't think so.
Yeah, probably not.
No, I mean, I don't know a lot about T cell biology, but I don't think most of them are out there.
Right.
I think they're sitting in lymphoid organs waiting to be.
Sure.
So
what they'd
activate.
have to do is, rather than take them out, you'd have to do this in situ. You'd have to work out
exactly.
this technology in the patient.
Yeah, right. To give them a virus that will target somehow.
Exactly.
And then you could walk into the clinic, get an injection,
Yeah.
and go home. And
No, I know. We'll do
Or
it.
it wouldn't have to be a virus, but some gene therapy mechanism.
We'll do it when
Yeah,
you're an embryo, and then everybody will be treated, and no one will ever get AIDS again.
Except, well, I mean, I know Vincent just said the CCR5 is apparently not necessary, but we don't really know that.
No, we don't.
well, these people are okay, aren't they?
No, but
Well, have you taken a...
To the opera,
that's right. Or can they repair a storm door?
Alan, are you still there, Alan?
Do
hello?
they fly fish?
Alan, hello.
Can you hear me?
We can
Hello?
hear you now.
I hear
We
you.
can hear you now.
Okay, you hear me now.
We can hear you now.
Yeah, so my question was, have you taken these people to the opera?
Right.
Yeah,
We talk about it. Have you really tested the phenotype of a mouse? Have you taken it to the opera? Why is this there? I know we're not supposed to ask why. CCR5, there's some reason why evolutionarily this got conserved
Well,
and why it's
people
expressed on CD4 T cells, and we don't know what that reason is. It could be something that is no longer a threat.
Right.
And evolution is kind of bureaucratic, so it adds stuff and then is very slow to get rid of it.
Sure.
This could be something like that. Maybe this is like having your appendix out, and it's not going to do any harm. But I'd be hesitant to start.
I wouldn't say appendix. I wouldn't go there.
Right. Actually, good example. We thought that wasn't necessary. Now we're starting to think maybe it's got some use.
Exactly.
So this would be something where I'm not sure I would advocate doing this prophylactically.
Right.
Well,
I mean, are all the people with this double mutation, are they all male? Are they all from Central Europe? Are they all
well, they're not all male. They're of European descent.
They're from a given region.
Yeah, and that's a good question. Why was this deletion selected for in the first place?
Exactly.
We don't know.
Was there some earlier infection that wiped out a lot of the population that?
Yeah,
that's right.
That this confers
and
immunity.
These were the ones that were left.
Yeah,
but
is this like sickle cell trait?
Sure.
Right.
I have a defect. It's not a big defect. It's called Pelger-Hewitt syndrome. Pelger-Hewitt.
You have this?
I do.
Oh, that explains everything.
It does. It's a non-segmentation of your neutrophil.
What does that do?
Nothing.
All right.
Not a darn thing. But it looks as though you've got an infection because that's called a stab in most people because you get you get a bone marrow throwing out of the neutrophils to respond to an infection, and it's one way to tell whether you've got one or not. It's called a shift to the left. But when I took clinical pathology here as a student, we all had to do our own blood smears.
Mm-hmm.
And when I did mine, I found out that I had Pelger-Hewitt, which is a Middle European inherited trait for non-segmented neutrophils that has virtually no effect at all on the functionality of a neutrophil. They can still engulf and
well,
devour.
let's put it this way. Given what we think we know about CCR5 null people, what would you pick, being CCR5 null or having AIDS?
I'm going to tell you right now. That's an easy decision.
All right, so I think that's the thing you should talk about, because even if in 40 years we figure out that you're susceptible to something or whatever.
They can't hit high C, so what?
Or something else more serious. But for now, this is the better of the two. So all right, let's read some email. And Kathy, could you take that first one, please?
When I get back to my
Google
Doc. Yep. Okay, that was
right.
kind of a fast transition. So Attila writes, "Dear Professor Racaniello and other TWiVieros," which is Portuguese for Twivers. It has been a long and busy time since I last wrote to TWiV, but I'm still listening from here. It's a nice 27 degrees Fahrenheit here in New Haven, Connecticut, where I'm postdocing for this year, or a rainy 21 degrees Celsius back in Sao Paulo. I've been moved to send us an email by the recurrent discussions on open access and high impact periodicals, and would like to share my inexperienced opinion. Now that we use search engines like PubMed or my personal favorite, Google Scholar, the title of the article is much more evident than where it was published. How many citations they receive also seems to be one of the sorting criteria in Google Scholar results, and people read each time less of an entire journal to find relevant research. Meanwhile, journals like Nature and Science still publish very important research, but they, quote, have been publishing a decreasing proportion of these top-cited papers, end quote, as Lariviere et al. Pointed out last year, and he gives a link to that. This means that they still have a very high impact factor, but are not keeping pace with the diversification of journals. Things probably will get worse with the adoption of article-level metrics so prized by PLOS and others, as the fraction of highly cited articles that sustains the high impact factor is very small. Not surprisingly, I've been hearing and reading more and more from top journal editors about how much grant money or professional influence they provide. Please see this Nature editorial full of testimonials on how a publication at their journal led people to get a job position or win a grant or clinical trial proposal, which is to say that their actual relevance is sustained much more by committees and grant review panels than for scientific reasons. I think what Clay Shirky wrote about scribes, music industry, and others in the book Here Comes Everybody can be applied here. When some business models collapse or change too fast, as is the case of scientific publications, the first reactions from institutions that profit from the old model is to try to stop things from changing. By giving so much importance to where the articles were published instead of what they contain, we're just helping this. Thank you all for the great discussions and for the first true international virology meeting. Best, Attila.
I like that.
It's good.
Like that. This is really good. I thought this was a really
very
thoughtful
articulate
letter.
Yes.
I don't know. I expect Alan will want to say something.
These are excellent points. This whole thing about impact factors, it's definitely kind of the crux of the matter. The top journals are the top journals because they have high impact factors, but if you look at the articles that are driving those, you find that it's a tiny minority of the articles they publish that have given all these citations, and then a lot of the stuff that's published in Nature, Science, and Cell is not cited that much. So this is exactly why PLOS is advocating article measure metrics, because it would favor them. They publish a whole lot of papers in their various empire of journals, including PLOS One, and some of them go viral, you might say, and rack up a lot of citations. And if you do article level metrics, then obviously that would undercut a lot of the impact factor impact.
And the other journals can't have article level because they're closed, right?
Right.
Yep. So it would be a false measure of the impact, I guess.
Yep.
Yeah.
I think that it's, as we have said before, the publishing is changing. It will happen slowly, but hopefully we get to a more fair point at some point in the future. But the fact that Nature and Science are defending, what they do is sad in a way. But they shouldn't have to do that, right?
Right.
Yeah, I mean, they're in a tough spot. This is an existential threat to these journals.
Sure.
The at least the really extreme folks in the PLOS camp or in the open access camp would like to see those journals gone.
Right.
And if you are Macmillan, this is a very bad thing.
Yeah. Right.
But as you know, in all industries, companies go out of business.
They do.
Look at tech, where they go left and right.
Right.
Many, many times. And even companies that seem wonderful, digital equipment company, right?
Yeah.
Gone.
That's right.
Yeah, it's happened. So I think...
Yeah.
But when you're talking about an entire industry sector like that, it's it's a bigger deal. I mean, it would be like if the entire automotive industry was suddenly under threat.
That almost happened, Alan.
Well, no, only a few companies in this country who build crummy cars.
Yeah, well,
it wasn't that Honda was going out of business.
No, that's true.
So it's not that nature is under threat because they've run their business badly. It's that their whole business model for that entire class of enterprise is being undermined.
Mm-hmm.
And I do think it's being undermined. I think people need to figure out where to go from here to have the stuff that's important, which is the papers. And if the journals are arguing that they add value to that, and I think some of them do, then they need to figure out how to provide that added value in some other model than the one they're using right now. But that's very hard to implement.
Yeah, I mean, you get into the problem of clubbiness also for people. Says, I only had 2 papers in Cell last year, or 5 papers in this, or or you had one really great paper in, and everybody knows these articles, and they all refer to them, and they all stand in awe of them, and it's very difficult to avoid that as a postdoc or as a new faculty member to try not to get involved in that kind of controversy.
Well, that's why it's hard to change, Dickson.
Yeah, I understand that. Half of the world doesn't want to change. So
not to put all the blame on the supply side of this, on the academic side, the open access advocates are disproportionately tenured.
Yeah, right.
And they're saying everybody should publish everything open access,
exactly.
and somebody's a postdoc who's looking at applying at a position where 300 other people are applying, and they've got a choice of sending their work and maybe getting it published in Cell versus maybe getting it published in an open access journal. They're sending it to Cell.
I know.
Because they want the job, and that's what's going to get them the job.
Sure.
So as long as these academic biases persist, you're supporting the old order. And if you have a problem with that, then you need to make institutional changes.
Well, I guess we've talked about this quite a bit.
Yeah, we have.
So let's move on to...
Shall we?
Alan, can you take the next
You
one?
want Alan to take this one, even though he's mentioned in the article?
Yeah, that's why I want him to take it.
All right, let him toot his own horn. Go ahead.
Tim writes, TWiVers, I started listening to your program when the XMRV debacle started. I guess I was in the category of what Alan at the time called a bunch of crazies. Did I use that term?
Oh, yeah.
Oh, many times. More than the article type stuff.
Eventually, I found my way to listening to TWiM also. Not being a microbiologist, but being a scientist, I appreciate that you try to find subjects that sometimes are applicable to the public. I really enjoyed episode 271 on viruses that may have crossed kingdoms. I'm curious about a phenomenon I seem to have noticed, and which was mentioned in episode 271. It seems to me that the press releases concerning the publications of research papers have moved into the realm of hype and unfounded claims of new discoveries. Have you noticed this also? Any speculations as to why? Is it the competition for research money, and thus income to the research institution, just so great that this is the result? If I was one of the authors, if I was one of the authors who put so much time and effort into producing this paper, only to see it being touted with unfounded claims, I would be upset. For a listener pick of the week, I want to nominate Alan Dove's recent attempts to explain the scientific thinking and the scientific method to the general public on his website, The Turbid Plaque. Nice work, Alan.
Yeah, see, that's why I wanted him to read it.
Thank you very much, Tim.
No,
so what do you think about the press release question that he has?
Oh, yeah.
Yeah.
Oh, well, and the question, it's kind of amusing to see it phrased as the press releases have moved into the realm of hype and unfounded claims. I came into the science journalism business 15 years ago, and they were already there. They've gotten further along that, but I think the reason for that is there's so much noise. And everybody's got to shout. It feels like they have to shout to be heard. So I look at the press releases that are coming out, because that's often, a good way to find new papers that might not have come to my attention otherwise. And as I'm skimming through them, it's hype this, hype that, hype this, and everything is a breakthrough and a game changer and all these buzzwords. Because everybody else is saying the same thing. So there's a feeling that if you don't hype the research, you won't get noticed by the reporters who are flipping through the press releases.
Well, I guess the solution is just to get rid of the reporters and the press, so you don't have to worry about that, right?
And then you have no communication with the
Exactly.
public.
Right.
Yeah.
Exactly.
Well, we can communicate science without the reporters, so that's no problem. Now,
Good luck with that.
This was, we're working on it now.
Yeah, this actually, TWiV works well, but you're an outlier.
Oh dear. Well, Alan, this letter came many, many weeks ago, and actually, Rich had made your site a pick of the week, and I complained about it, and we talked about that. But in the meanwhile, Suzanne picked up my complaint, so she wrote, I will agree with you that real isn't the best word to use. I don't know what it is. It's always annoyed me when people use the word real to talk about any one section of the population. I know what they mean, but we need a better word. On the other hand, I do agree with Alan that the people he's trying to reach who really need a primer on how science works aren't listening to your podcast. Yeah. That's okay. Thank you, Suzanne.
Yes.
Your podcast is great outreach to a lot of the non-science community population, and the info you share does get filtered out even further than us. I don't think the science media is a complete echo chamber. Also, plenty of us could use a refresher or a follow-up course on basic science, and those videos are useful for that. So there is overlap, but it wouldn't surprise me if there is a much larger audience that just needs to know how science works before they can even listen to someone like me talking about what I heard you say and really get much out of it. That's great.
Yes.
Thank you, Suzanne.
Yeah.
All right, now, Dickson, I timed it so you could read one where you're mentioned.
You did? Oh, well, in that case, then I'll just perk right up. Joe, how do you pronounce his name, by the way?
Johnny.
Okay,
it's
Johnny.
a she.
She or him.
See,
or
Dickson,
she.
you got to pay attention.
Oh, you know what? My book just, no, here we go. Okay. Johnny writes, greetings from Chile, -5 degrees centigrade, Boston, Mass.
Is that possible?
I guess.
Oh, yeah, it is possible.
It was then.
I'm sorry. Yeah, it was really cold.
It's Celsius. It's not
Celsius.
Burr, yeah,
Right.
Celsius. Special thanks to Prof. Despommier for his pick this week. Ronnie Turtney's artistic images of liquids colliding. Can't help but think there are physics majors who could translate the images into equally amazing graphs and equations. At the Yahoo News site, I came across macro views of snowflakes. Yeah, that's cool stuff, too. Taken by photographer Valeria Zvereva. That's bad pronunciation. Zvereva. Seemed most apt, given the current weather pattern here in the Northeast, and thought I would share now to listen to this week's TWiV. Stay warm, Johnny.
They're pretty nice.
Nice. That was nice.
Yeah.
Poorly read. Very nice letter.
Yeah,
Sorry about that.
Dickson, we are very patient with you. Did you look at the pictures, Dickson?
I have a book on snowflakes at home.
They're very pretty.
Fantastic.
Snowflakes are
by the way,
gorgeous. I'm flipping through them right now.
Probably no two alike.
Is everyone different?
Actually, I have the book. I have that book at home.
There's one that doesn't have branches. It's
That's
just
right.
Yes.
like
That's right.
a triangle.
That's correct.
I just got to that one.
I think it depends on the rate at which they freeze as to what they look like. And everybody freezes at a different rate.
Yeah.
Yeah,
Oh, and then-
individually they're beautiful. It's when they get together that
That's right.
Yeah. Oh, and then there's a picture at the end of the photographer, so you can see the setup.
Yeah.
Oh,
yeah,
yeah.
That's really cool.
Yeah.
That's a real macro view.
Indeed.
Ricardo sent a link to an article in Mother Jones.
Oh, yeah.
How many people aren't vaccinating their kids in your state?
Yeah.
So it is a very nice
Look at Oregon. Gee whiz.
set of
Michigan.
information about which states are having bad vaccination rates. Quite interesting. So, yeah, Oregon is really... And look at Michigan is not so good, Kathy.
No, Michigan and Idaho.
What's going
And
on?
Vermont.
Vermont, Illinois.
Vermont's got
Lord.
problems.
Are these counterculture people we're looking at here?
Massachusetts and New Jersey are tied, it looks like.
New York is good.
New York's good.
Yeah, well,
Virginia.
compulsory vaccination or you can't go to school.
And then...
Well, they have that in Massachusetts, too.
Well, they don't want to go to school.
It's so one of the issues is how easy it is to get, and in fact, they have a nice graphic of that. How hard is it to get a vaccine exemption in your state?
Yeah, that's a good one, too.
Yeah,
And there is some correlation between how hard it is and how many people opt out of vaccination.
Yep.
My pick is actually related to this, but this is pretty good.
Yeah, there's some states where you need a notarized form or both a form signed by a healthcare professional and a letter of explanation.
Do you think that's a reason why people homeschool a lot?
No, I don't
Because they
think
don't
so.
have to vaccinate their kids.
It may be one driver. I think religious issues are a major one, or just living in a crummy school district.
Right.
Homeschooling is not easy to do. So
No, of course not.
It is not.
So I'm not sure that people would do that, but maybe, you don't know. Let's start at the top. Kathy, come back to you, and that brings us to Bill.
Okay? Folks, I've discovered the TWiV podcast about 18 months ago, and I've since given up trying to keep current and listen to all the previous podcasts. So please forgive me if this has been already mentioned. Dr. John Janovi Jr. taught parasitology at the University of Nebraska-Lincoln for 40-plus years and is now retired. Dr. Janovi has written a number of books dealing with various topics, but I think that his nonfiction works dealing with the training of young minds to be scientists are very good. Everything from his early material, Keith County Journal, Return to Keith County, Yellow Legs, etc., to more recent works, Dunwoody Pond, Pieces of the Plains, etc., are very good reading. Since I am a physician, I tend to work in the realm of applied science rather than in the pure science arena. Dr. Janovi obviously failed in converting me, but I still understand the importance of formulating clear questions and getting people to think rationally and realistically about things.
Yeah.
Again, please forgive me if this material has been previously mentioned. Disclaimer, although I currently practice in north central Pennsylvania, I am a Nebraska native and my perspective may be somewhat biased. I very much enjoy the TWiV podcasts and I have learned very much from listening to them. I will continue my efforts, which I fear are futile, to get caught up and then remain current. Sincerely, Bill.
Well, I actually know Dr. John Janovi Jr. He's a contemporary of mine.
Wow.
And he's a highly respected parasitologist and a fantastic teacher, and he's trained many, many, many parasitologists. So if Bill wants a refresher course in parasitic diseases, all he has to do is go to TWiP.
Where can he find TWiP, Dickson?
I believe he can find it on iTunes, and he can find it on lots of other places, too.
Yeah, well, what is this lots of other places, for example? You don't know, right?
Well, I know some of them.
In the Zune marketplace?
That's right. Keep
Dickson,
going.
I think that's defunct, actually.
Just type out TWiP on Google search, and you'll get it.
Actually, I think you're going to get This Week in Photography.
No.
Yep. You
And
get
This
then
Week
the
in
next
Photo.
one, and
But
then
it's
the
two.
next-
We're number two.
We are number
And
two.
I got number 2, TWiP, abbreviating 20th of a point from Wikipedia.
Really?
Yeah.
Yeah, it's number 3 on mine. That's interesting. I didn't know that. Oh, I didn't know you knew this guy. That's good. He has a lot of books. He has more than you, Dickson.
Many more.
A lot more than
And
you.
deservedly so. I mean, he's an
right.
intellectual.
Alan, you are next.
Wait, I just have one little hint for Bill.
Sure.
He could, depending on how he's listening, but his smartphone podcast software might allow him to listen at 1.5x speed, and that might be,
Yes.
through the weather and the stump grinders and stuff like that.
Right.
Slow
the
down
science
for the
method.
weather and the stump grinders.
That's right.
The good
That's right.
stuff.
Stump grinders.
Stump grinder.
Yeah, one
And
and a
Waffle.
half or 2x is pretty good.
Yeah.
Kathy, Mauricio.
Bill.
She just did Bill. It's my turn, I think.
Oh, sorry. I'm sorry.
Unless it's
Alan.
your turn.
No,
That's-
it's your turn, Alan.
It's my turn.
Yes.
Okay.
Yeah.
Mauricio writes, Dear TWiV team, How are you enjoying the winter?
We love it. We are having such a wonderful time.
Here in Frederick, Maryland, life has been slightly challenging, mostly because every time we have some snow or ice, they close Fort Detrick, where NCI Frederick's main labs are located. Yesterday, we had a nasty winter storm, but right now it's a wonderful 0 degrees C with a thermal sensation of 4 C and 24 kilometer per hour winds. That must be a thermal sensation of minus 4 C, I think.
Yeah, I think you're right.
And I'm quite aware of how the flake of snow closes the state of Maryland. That is quite true. I had a blast, like most of the time, listening to podcast 267, where you discussed the paper by Shushan Harutyunyan about viral uncoding, where they use fluorescence correlation spectroscopy to learn if there's any directional uncoding. During my last year and a half of my PhD, I used FCS to measure the number of multiple copies of packaged RNA by a plant virus capsid protein, all in vitro work. And I got hired at NCI to keep doing FCS experiments to study HIV-1 gag RNA interactions. Anyway, I want to point out that the work done by Harutyunyan is brilliant and extremely challenging. What I liked most about the podcast was the way you explained FCS and what an autocorrelation function is, specifically why it goes from 1 to 0. I would like to point out 3 more things. 1, you can know the exact number of molecules in your confocal volume, and from this information, you can quote-unquote count the number of molecules interacting. 2, you can follow chemical reactions or binding events at different time scales, from microseconds to several minutes long. And 3, you have to work in a very dilute regime, so there are between 1 to 10 fluorescently labeled molecules in the confocal volume of about 1 femtoliter. Working in this dilute regime is what gives FCS a great power when looking at in vitro viral assembly. Most techniques require very high concentrations to determine the size of a molecule, and most of the time they cannot discriminate between different kinds of molecules present in the same sample. For example, it's thought that in the cell, just a couple of HIV-1 GAT molecules interact with the virus genomic RNA. They're from the Beniage lab. There are no other techniques that could study H1. Yeah, gag. I was like, wait, GAT. I don't know that one.
Is that a gun in your pocket, or are you just glad
just a couple of HIV-1 gag molecules interact with virus genomic RNA? That makes a lot more sense. There's no other technique that could study the strength of these interactions under such diluted conditions. Of course, there are a lot of artifacts which limit your system, but those are very technical details. I hope this technique comes back because it's extremely useful both in vitro and in cell work. Mm-hmm. You all did great explaining something that's very obvious for a spectroscopist, but not for other scientists.
Great, thank you. That's very nice.
Yeah.
I'm glad we didn't screw that up.
We had many opportunities, however.
We had plenty of opportunities, yes.
Rich really did his homework on that
Rich
one.
was the one who did that.
Yeah.
He was into it. Dickson.
Christopher writes,
Yeah.
Hi, Vincent et al. Christopher here again. I have been thinking of making some sort of T-shirt/sticker idea for you guys as a thank you for the crazy amount of work you all do with the TWiV, TWiP podcasts. And I really like the mice lie, monkeys exaggerate bit you guys keep saying. Anyway, here is a first effort. Hope you like it. Feel free to use it any way you like or not at all. P.S. The gray shape in the background is a silhouette of the polio virus. Nice going. No idea how accurate it is. That's all right. We'll let you know. And I am a web designer after all. Maybe I should do a pox version for Rich and Racaniello for Dickson. You bet. Not sure what Alan and Kathy would like. Well, ask and you shall receive. Yeah. Let's take a look.
You guys
at
look
this.
at this.
Let's take a look.
I'm looking at it now. It's pretty
cute.
cool.
Yeah, it's nice. It's very nice. Yeah. Mice lie, monkeys exaggerate, and ferrets are not people.
Ferrets are.
I'd wear that T-shirt. Mm-hmm. So we'll put it on the website so people can make their own T-shirt.
Oh, yeah, look at this.
It has a mouse and an ape and a polio in the background, which is fine. It's polio receptor image. It's fine.
Should probably send it to Paul Simon and Art Garfunkel as well.
Why?
You never heard their song "At the Zoo"?
Yeah, I don't.
Come
put
on.
That. I'm not quick on the music thing, Dickson.
That's okay.
What do you want, Kathy, on your T-shirt?
I have to think about that.
Okay.
Right.
Alan, what do you want?
Oh, I don't know. Poliovirus is fine for me.
Dixon, you want Racaniello?
I want the nurse cell. I gotta have the nurse cell. Just gotta have it. Gotta have it.
You gotta have it?
I gotta have it.
All right. Stephen writes next. Thought you might find these graphics about vaccine exemptions interesting.
That's the same one.
Yeah.
It's the same one. It's Mother Joe's.
It's
Yeah.
the same
All right, I have to group it up.
Yep.
Let me do Marion's.
Please.
She writes, everybody complains about the weather, but nobody does anything about it. Well, it appears that we are changing the weather by changing the climate.
There you
Yes,
go.
indeed.
Yes, we did say that a few times.
Yeah.
Transcytosis of secretory IJ has been known about and understood for a long time. Yes, so Rich was surprised about transcytosis. I forgot what we were talking about it in reference to.
I don't remember either.
And reasons for flu vaccination. Another important reason for flu vaccination is to reduce transmission by asymptomatic carriers.
Very good point.
Yep.
And
All right.
wasn't there just recently another paper about frequency, the asymptomatic infections with flu may be even more common than we thought?
Yeah, there was. We didn't do it, though, right?
No, I saw it. It blipped across my radar as I was reading through stuff. I said, oh, yeah, okay.
Right. All right, that brings us back to Kathy.
Andrew writes, Dear TWiV comrades, I am currently a student at Penn State Behrend of Erie, Pennsylvania, in the undergraduate fields of biology and chemistry. I stumbled upon TWiV, TWIM, and TWIP while I was attending Jamestown Community College to obtain my associate degree in science of biotechnology. I thought this podcast was perfect to listen to while driving, so I could reinforce the main ideas and details that I learned in some of my classes, i.e. virology, cancer biology, cell and molecular biology, immunology, and genetics. Since the day of discovering the triad, TWiV, TWIP, and TWIM, I have graduated from Jamestown Community College, transferred to Penn State Behrend, and now have a 50-minute drive to school each day. The drive makes excellent time to catch up on the episodes I missed, and I usually listen to one each day. I had enough with introducing myself and onward to my response and question.
Well, we like that.
That's all right. Now we know who you are.
First, I have a response to the discussion of GMOs in TWiV 272 and the cause to health effect that they cause. Since I am a man of science and biotechnology, I don't agree with the conjecture that GMOs are causing a dramatic increase in food-related illnesses, cancer in particular, just by observing an increase in instances of these types of diseases and the coincidence of using GMOs as food. These types of diseases are theorized to be related to diet and habitual practices, e.g. smoking, and certainly cannot be inferred to be caused by mutant recombinant DNA inserted into the genome of an organism. With this said, there is one type of carcinogen that is used in the food growing industry that may be responsible for high cancer rate incidences, if indeed the cause is in the industry. Chemicals like herbicides and pesticides are two examples, and when used growing GMO crops. It is known that some pesticides used are carcinogenic, as told in the literature Pesticides in Cancer by Ditch et al., and he gives a reference. And I wouldn't doubt that there are herbicides involved in causing cancer too. It is truly a silent spring-related issue. Now, the advances that Bonning BC et al. Made it possible to create areas of land where the crop has a higher fitness without the use of toxic chemicals to which the crop is resistant or immune. Theoretically, assuming no drawbacks are found and cancer instances are due to the carcinogens introduced into the environment from growing monocultures, if other studies like this are done and they are applied, the use for these chemicals will be eliminated. Therefore, the theoretical drop of cancer instances. Overall, this is an excellent study, and I applaud the authors and investigators. Now for the theory and questions. During my studies at PSB, I was required to take a survey course on ecology. While taking this course, I realized the importance of ecology to and the application the theories discussed, other biological disciplines, and so I am taking a 400-level population biology course, and I reviewed the major theories from that class. During the period of time that I was reviewing this material, I made a connection between it and TWiV, particularly one of the episodes about sequencing bat viruses. In the class, we discussed the theory of island biogeography and its 5 important postulates. 1, the closer the island is to another landmass, the higher the probability of colonization. 2, the older the island, the more likely it will be colonized. 3, the larger the island, the more species are likely to be established. 4, geographic isolation reduces gene flow between populations. 5, over time, colonial populations become genetically divergent from their parent population due to natural selection, mutation, and/or genetic drift.
Right.
Also, this theory is illustrated by a graph relating the probability or rate of colonization that is influenced by the relative distance from the mainland, and probability and rate of extinction is influenced by the size of the island with the species richness of the population. And he attached a figure. The illustration relates postulate 1 and 3 in respect to species richness. Now, if we state that an island is an organism, for example, a bat, then in theory, the size of the organism or the size of the island influences the species richness of the microbes housed inside the organism, according to postulate 3. This means that theoretically bigger organisms will then house a richer range and more of those microbes, like viruses, assuming contact between the mainland, the rest of the population, remains constant. In addition to the size of the organism, during an infection, viruses replicate in great numbers, and in theory, this creates interspecific and intraspecific competition between viruses and different strains, for example, influenza strains, respectively. Therefore, bigger organisms will house more viruses. Since all the background information is said, my questions are...
Thank you for that course.
Yeah. Has there been a study or studies to compare the quantity of the richness of viruses or microbes in particular organisms to members of the same population but with different sizes?
I'm not aware of any.
Not either.
I don't know. There's a thesis project, okay? Has there been a study to observe the interspecific and or intraspecific competition between viruses?
Not in nature, as far as I know. I mean, it's been done in the lab, of course. Simple competition experiments, but no, I think that's very hard to do.
Yeah.
And I'm not aware of any.
In fact, some viruses require other viruses for their replication, right?
Absolutely.
So there might be cooperativity also.
I'm sure there's some competition, especially if they infect the same cells, right?
Sure.
But I don't know how you would... I don't know how you would study it, right?
And I think this this analogy actually kind of breaks down when we go from islands to organisms. The reason that islands display this function, where smaller islands have one pattern and larger islands have another and more diversity, is that there are more ecological niches available on the larger island, and there's more territory.
That's right.
A larger organism doesn't necessarily have any more niches than a smaller one.
Right.
So a bat has a nervous system and a digestive system and a circulatory system and so on. An elephant has a nervous system and a digestive system and a circulatory system in the same systems. And you'd have, yes, probably a larger total number of cells in a larger organism, but that doesn't really map directly to the features that a larger island would offer.
I would agree.
And I think the closeness to the mainland thing would have the most to do with a species' range and mobility. So I would expect flying species to be like an organism that is close to other organisms, and maybe something like a plant that's immobile would be at the other extreme and would have less direct contact with other organisms in its vicinity. So that might be the way to push that analogy, but I don't think the physical size aspect of it is quite the same. There may be a function with simpler or versus more complex organisms.
But don't you think that a smaller organism would just have a smaller load of virus concentration, say, than a larger one, just because there are more cells and more niches in the bigger one? Right?
Maybe if you're looking at total virus concentration, but but in number of species, I don't think the number of cells matters nearly as much as the number of niches, and the number of niches is going to be pretty much the same in any mammal. But you'd probably have fewer niches in, a jellyfish.
Yeah, right.
But when you're talking about niches for viruses, you're not talking about extracellular. You're talking about intracellular niches.
Intracellular, so different cell types.
Yeah, exactly. But I mean, for instance, I guess the question would be if you put in equal numbers of viral particles of two completely different viruses that both located to the nucleus, and they both got there at the same time, which one wins? Or do they both win? Or do they both lose?
Depends on what their life cycles are.
Well,
there are lots of steps in between getting to the nucleus, right? So they can differ.
So that's the answer then.
Yeah, the receptor, for example, just getting to the cell.
Yes.
Mm-hmm.
But there are no barriers set up by the first virus to keep the other viruses out because it wants the cell all to himself.
Some viruses interfere with the infection of cells by others. Mm-hmm. So some retroviruses, when they infect, they put a viral protein on the surface that inhibits infection by other retroviruses. Interference, there are other examples of that.
It would be in their best interest to evolve.
Viruses don't have any interests. it's all
this is true. They're not even organisms. What am I talking about? What silly things?
They have interests. They just are, responding. They're selection.
Yeah. But the questions that he's raised for island biology is great. Terrific.
No virus is an island.
That's right.
Anything else there? Yeah. You want to read the last two, Kathy, or you had enough?
Oh, sorry. I was doing something else. So,
I could read the next one.
Yeah, let Dickson.
So wait. We're not done with this one.
We're not done with this one.
Just read his last two sentences.
The podcast
I was listening to when I made this connection, I believe, was TWiV 258, but I'm not 100% sure. Thanks for taking the time to read, critique, and answer the questions in my email. I am sorry for the explanations if they are not needed.
Oh.
Happy TWiV or swimming.
Yes.
We're always needed.
Yeah.
Thank you very much.
Yeah. And yes,
that
was
Dickson.
from Andrew.
He has a good quote. He has a good quote. The quote is, "We are healthy only to the extent that our ideas are humane." Kurt Vonnegut, Breakfast of Champions. Kurt writes, "Hello again, TWiV team."
Not Kurt Vonnegut.
Kurt.
Right.
That's right.
Is he dead?
Indeed. In the face of the mounting problem of antimicrobial resistance, some quick research revealed phage therapy as a possible alternative to antimicrobial compounds. I'm certain you guys have had to have heard of this, and some studies have shown promise against resistant infections. He gives a website. My question is, why don't we seem to be putting more effort into developing bacteriophages as viable, regular use antimicrobial therapy? P.S. In taking your Coursera virology course, I noticed that you mentioned that viral glycoproteins are visible on the cell surface before the virion buds off, if that's how the viruses escape from the cell as opposed to lysis. Wouldn't that make a persistently infected cell vulnerable to an antiviral lytic virus by engineering a virus that binds to the target virus's entry protein while the virion is still budding? The idea would be, for example, to use influenza, not persistent, I know, HA, to enter the persistently infected cell, replicate, and destroy the cell, thereby preventing the further influenza proliferation. Has anyone tried this before? I hope my explanation isn't as convoluted as it feels. Thanks for your time and hard work, guys and gal. It is appreciated. He didn't say gals, he said gal. He said gals, but I say gal, right? Because we only have one gal here.
Sometimes we have other gals.
We do, but with a regular.
Yeah.
Okay, fine.
Well,
what do you think about that?
So bacteriophage therapy is indeed being explored in many places. There's actually a phage license in the U.S. by FDA to clean surfaces in kitchens to make sure the bacteria are destroyed.
Right.
And there are companies in the U.S., all over the world, trying this. It's not easy.
Right.
There are all kinds of problems. We have actually talked about it on 2 different occasions on TWiM. So if you go over to microbeworld.org/TWiM, we did an episode in Manchester last year with a guy from a company. The name of the company is based on Phi-X, I think. It was very clever, which I've forgotten. He talked about the problems they have. And then earlier we did a review of it as well. And Michael Schmidt, our co-host, actually did some work on phage therapy. And so we talk about all the issues. So rather than going into them here, you should go there. As for this idea of, you see, the thing is, in a truly persistently infected cell, there are no viral glycoproteins on the surface. That's why one of the reasons why it's persistently infected. It's evading elimination. So herpes simplex viruses are the most persistent or the most stealthy. They just have their genome in the cell. They don't make any proteins. They make a little RNA. So the idea is great, and that's what our immune system for. Our CD8 cells are supposed to do that whenever there's a viral glycoprotein on the surface. They're supposed to kill the infected cell. So a true persistent infection, which is defined as lasting the lifetime of the host, shouldn't be vulnerable in this way, and that's why they're hard to clear.
Right. But you can think of some bacterial infections that you would just love to have phage therapy for, and C. difficile is one of those.
Many, but there are many problems. And
understood.
It works, and there are limitations. There are positive things.
Yep.
Go listen to the 2 podcasts because we went into them there, and we could do a whole one here.
Maybe you can put the specific podcast link numbers in the show notes or something, or in this email,
I should,
near this email.
Put TWiV numbers in email. Okay. Did you read that, Dickson? No, you didn't read it?
You
read the last email.
Yes,
all right,
so
let me read.
I read that. Did I read? I thought you meant the last 2 podcasts. I'm sorry.
Right, Dickson. Let me read one more.
I'm daydreaming. I'm actually reading this thing here.
Let me read one more, Dickson.
James. Yeah, please do.
James writes, Dear TWiV team, thanks for a fantastic series of podcasts that keep my mental stimulation into science going while I work in a less stimulating environment. Which he does not specify.
No.
In episode 272, one of your picks concerned the over-reliance on statistical data. While I share some of the concerns, such as the difficulty that can be perceived in attempting to get published without a p-value or 3, I do wonder if some of the concern addressed both in the article and in discussion is the age-old horror of statistics. While myself, I feel very confident with statistics, you might even use the word like, I found most of those around me when I was studying in the biological sciences, even those asked to teach at undergraduate level in some subjects, don't enjoy the subject at all. Furthermore, inappropriate use of an inappropriate statistical test can result in desired results. There are, however, very few situations where you can select the statistical analysis to apply. If you're doing it correctly, there are usually only a few or one test that can truly be selected. This, however, as is usually the case, is not often fully understood and leads to even elite publications selecting to publish articles applying the wrong statistical test. I think the problem is going to remain. While I enjoyed and understood statistics naturally, I was taught well by lecturers who begrudgingly had to teach it but did this well. Largely, I suspect, because they worked in areas where IT could not be used, too cold, and so to get results on the fly, they had to apply preliminary tests by hand, so having a full understanding of the subject beyond most of us. My cohort still hated the aspect of the course, and I helped many of them. My partner in another discipline during undergraduate studies, however, was less lucky, and despite the unit of study being almost exact, the tuition was not as easy to follow. I had to decipher simple questions just so I could begin to help her and others on the course, the problem being non-specialist teaching. Follow this with stories I have heard of statistics departments in universities, instead of being cooperative, charging departments for 4-figure sums just to spend an hour to look over already worked figures to ensure accuracy. How can we hope to resolve the chicken-egg situation? 4-figure sums. Yeah, that happens. You got to pay for their salary. The larger question of whether p-values and statistics should be important takes me back to when, as part of my dissertation research, I went to a collaborating vaccine development lab at university for the Western blotting stage. A member of staff there was talking about their career path. They started studies in ecology but hated the wishy-washy results, eventually moving to disease and virology because they can run tests and get, quote, results, unquote. It's no longer wishy-washy. Ecology is very, very molecular now. Right?
It's molecular, but even if it's visual, you can quantitate the visual aspects.
Yeah, of course.
Yeah.
Absolutely.
So lots of stuff, lots of great stuff going on out there.
London is very clear, bright, and sunny today at acceptable 10 degrees C, 49% humidity, and I can currently see right across the city, much warmer than my home where it is 6 degrees C, but feeling like minus 2 degrees C. So the internet tells me. Thanks. All right, thank you. Statistics hit the nerve.
Yes.
I knew someone who called them sadistics.
Oh, that's interesting. That's very interesting.
It's Phil D'Alessandro.
All right, let's do a couple of picks of the week. And Dickson, do you have a pick for us?
I certainly do.
Wow, there's a lot of email here.
I have a pick of the week.
I'm still scrolling.
Me too.
The pick of the week is from the March 14th, 2014 issue, volume 343 of Science, page 1184.
Oh,
it's just a blurb. It's a blurb, okay? Who reads the
March
blurbs?
14th?
Yeah.
Okay, and what page again?
It's on 1184. It's a fantastic little blurb. It starts out saying, font of knowledge. All right? It's from Random Sample. It says, 14-year-old Suvir Mirchandii says the U.S. government could save hundreds of millions of dollars simply by changing the font of its printed documents, and he's got the numbers to prove it. And when he went through his analysis using Garamond versus the Comic Sans, for instance, to show the differences of the two fonts, he said at the bottom that an across-the-board switch to Garamond could save roughly $234 million a year. Now, let me ask you all out there, could the NIH use an extra $234 million to fund extramural research? You betcha. Could the NSF use that money? Could lots of other science programs use it? And just because the font size has been selected because somebody said, oh, I like the way that looks, it costs the government an extra $234 million a year just to print.
They don't print anything anymore.
Yeah, but they do. Oh, yes, they do.
They still do.
Oh, yes,
I don't. When study sections don't print anything.
No, they're not talking about that kind of publication.
It's Arial 11 point.
It's that's smart. That somebody figured it out. That you can get more words per page if you just reduce the font size a little bit.
Arial at 11 point is actually quite large.
And you can still read it. Well, most.
I hate Garamond.
Most font sizes.
I'm not ever using Garamond.
I can tell. When I showed this to you, but look, come on, it's compelling.
Well, the solution is not to print anymore.
Well, that's true too. But
right?
If you have to print, you should use a font size that allows you to save paper.
Well, actually, for grants, you're not allowed to go below a certain font size
anyway.
It's my
pick of the week, and I'm sticking with it.
Right. Well, Times New Roman is one of the
Vincent.
Times New Roman is one of the fonts that was that they show on this graph in this article, and that actually was developed for the New York Times, I believe, for precisely this purpose, so they could put more news on a given page.
That's right. That's right. But there are even better
That's
ones.
a cool pick, Dickson. I'm not criticizing you.
Yes, you are.
I'm
yes, you are.
Kvetching. I'm just kvetching.
You're kvetching.
You'd prefer Comic Sans, right?
No, I don't prefer Comic Sans.
That's right.
I have other preferences for fonts, but
why don't you like Garamond? What does?
He's not very fond of it.
Oh.
I actually, at one point early on, I loved it, and then it just, I don't know why I disliked it, and I don't know, it's a little bit too rounded.
My favorite is Arial. I love Arial. I've started with Arial. I've finished with Arial. I just love it.
Have you read have you seen the movie Helvetica?
I have not.
It's all about fonts.
Yeah, no, I should go see it.
Kathy, what do you have for us?
Oh, again, I'm typing in a Word document to see what Garamond looks like.
I'm sorry. You want to? Should we do? Alan?
No. I'm fine.
I just changed Vincent's section of the picks of the week.
Yeah,
to
that's Garamond. Yeah.
I see. Yeah.
It's not bad. It's okay. I have more favorite fonts.
Yeah. Right. So I picked the winner of the Basic Science, Funding Basic Science to Revolutionize Medicine competition as the 2013 FASB Stand Up for Science. And I put it in late enough that I was afraid you guys didn't get to look at it yet. But it's a really well done video. I think it's about 2.5 or 3 minutes long, and they put up a whiteboard somewhere, and people got to vote. If you had $10 to spend in 1960, would you spend it on developing an affordable treatment for diabetes or conducting basic research on how bacteria protect themselves? Most people, of course, voted for the diabetes, but the video goes on to show that many more things besides treatments for diabetes came out of funding the basic research, including things like HIV meds, which relates to today's paper using restriction enzymes and all kinds of other things. So I just wanted, I can't remember whether I picked the contest itself. I had this vague feeling that I did, or I meant to, but this is this year's winner. So check it out.
Cool.
Yeah, they use the whiteboard marker technique, which can be effective. Yep. Not as effective as the Lego technique. Did you pioneer that, Alan? Has anyone else ever done that?
People. There's a whole genre. In fact, one of the tags I put on my YouTube video was brick film. There's a genre of Lego minifigure animations because those little Lego minifigures are perfect for it. They're easy to pose and.
I'm holding my little Lego woman scientist right now.
I was just going to say, you could use all women scientist Legos. That would
Yeah, the problem was I couldn't find that one. You can buy little packages of a random assortment, or I bought a package of just kind of a general assortment of them, and had to work with what I had.
Yeah.
By the way, as another aside, Kathy, did you hear NPR this morning?
Maybe not. What story?
There's a new head of the IMF, and it's a woman.
Oh, I think I did hear that.
She's the only woman executive at IMF, because all of the members are picked by each country. So she has no choice in the matter.
Yes.
And she said she was a lawyer, and her first job was in France. So she went to the biggest law firm in Paris, interviewed for the job, and they said, you can have this job. You will see many interesting cases. You'll have a wonderful life. You'll never make partner. She was told outright that you'll never make partner. She just said, well, see you later. Yeah. She moved on to another law firm. She was very happy. Anyway, I thought you would enjoy that.
International Monetary Fund?
IMF, yeah, she's the head.
Cool.
Yep, first time ever.
All right. Alan, what do you have?
A digital scale model of the solar system.
Digital model?
So if
with
you
the new planet they found outside?
Well, that's not on there, but if you click on this page,
Cool.
you get if the moon were 1 pixel. And you scroll to the right, and there's, this is the scale of it. The moon is 1 pixel on your screen, and there's the sun, and then you scroll. And scroll and scroll and scroll
right.
and scroll, and you go through. You can go through all the planets eventually.
Cool.
And there are shortcuts at the top if you really can't wait. But there are little bits of text in between that as you're scrolling, especially in the outer planets. There's a lot of space out in space.
There's a lot of space.
It's a pretty good illustration of a concept that's actually kind of difficult to get across.
Very nice. Looks like a little takeoff on Powers of 10.
Yes.
Pluto. I love the Pluto. We still love you.
That's right. That's right.
So just in case you have a browser like me or are a little bit challenged, I found that the scroll bar I thought the scroll was something to do with the blue arrow, and it's not. It's below that. And if you just click initially, then it takes you to an informative page rather than starting to scroll right away, because I think scrolling is a little harder to maneuver in reasonable sized chunks. So just a hint for others.
Yes. You're not challenged, are you, Kathy?
Well, and then I didn't notice all these other things up at the top until now. So, okay. And they take you right to certain things. And little words flash by very quickly.
Yes.
Aye. Okay.
And it moves as you click them.
Right.
It's very cool.
Right.
I didn't know that symbol was Mars. Huh. The male symbol is Mars. Did you know that?
Yeah.
Yes.
And women are from Venus.
Men are from Mars.
Men are, yes.
Women are from...
That's right. There you go. And what are all these other symbols?
Forget it.
They're just the other
They're
planets.
the other planets.
I thought we only had 2 sexes, though.
We do.
Well, no, those are the gods after which the planets are named.
Exactly.
By Jupiter. All right, never mind. I'm not going to ask any more questions.
Oh, please.
You didn't want to know anything about Uranus?
Did you know that there's a ring around? No, forget it.
Dickson.
Dickson.
My son.
I'm not Devin.
I do call you Devin sometimes.
You're gonna have to edit that one out.
No, I'm not editing anything. I know when to edit, and this one isn't. I have a couple of picks around measles. And I have these because yesterday we had a textbook meeting, and we reviewed the vaccine chapter, so these came up. And in fact, the first one is a Huffington Post article, which has some nice graphics. It's called Big Measles Outbreaks Linked to Troubling Trend. And these are religious and philosophical exemptions, but they have a map of the U.S. showing, the recent outbreaks. And there was a big one here in New York, 58 cases in Brooklyn. You have to sit by the mic, Dickson.
I didn't want you to hear
Okay. They're unvaccinated members of an Orthodox Jewish community. 23 cases in a unvaccinated Hare Krishna community in North Carolina. So lots of religious exemptions and no immunizations. And then they have a nice table of the different states and when there's an outbreak, if there was a religious or philosophical exemption associated with it, and they are. And then finally at the bottom, which I think is cool, is a line graph showing all the the cases, and then 79% philosophical or religious beliefs, and then a couple of other reasons. So it's kind of striking. And then I have another an article basically in Huffington Post also describing an ongoing measles outbreak here in New York City. There are 20 cases that have been reported so far, largely in unvaccinated children, and the article from the New York City Department of Health describing that outbreak. So here, failure to vaccinate is bringing measles back all over the U.S., and this is an entirely preventable disease, of course, and that the vaccine is entirely safe, does not cause anything untoward. And so there's no reason, no philosophical or religious reason not to get it. And measles can be fatal. The fatality rate is 1 in 1,000. You can get encephalitis.
Get SSPE.
You can get SSPE. You can get immunosuppressed. That's right. So this is really not good.
No.
And it is an extremely contagious virus.
Yes, the reproductive index is 15. One infected person will infect 15 others. So last week what's today, Friday? Wednesday, I was discussing this with my class, and one young lady said, but doesn't polio vaccine cause polio? And I said, well, yes, that is a different vaccine. We're talking about measles vaccine here, which you should get. And I said, we will talk about that another time. But, it made me realize that some people condemn all of vaccines when one causes an issue.
That's right.
Yeah.
Anyway, that's my pick.
Very nice.
And we went through everyone, right?
We did.
Mm-hmm.
Yep.
Do you want to leave, Dickson? Is that why?
No, I have something to say at the end of this, because the idea occurred to me while I read my pick of the week, that this was a 14-year-old kid that came up with this, okay? Mm-hmm. That's the real crux of this pick. Here's a 14-year-old.
Which pick? Your pick?
Yeah, the font pick. Yeah, so what if the government were to take his suggestion seriously, and what if they saved some... I have to put my glasses back on for this one. They saved $234 million a year, and what if the kid got 10% as a finder's fee? What if you had an annual contest among the citizens of the United States below the age of 20? Let's say you had to be in high school for this. Come up with a money-saving, easy-to-fix thing for the government, and there must be zillions of them.
I don't know that
20.
there are.
Well, here's one.
Here's one, yes, but why is it news?
Because
it's an outlier.
No, but I think because a 14-year-old kid came up with it rather than the government officials in charge of the publications. But what if you had such a contest, and what if the government took it serious? It was a government-sponsored contest, and real changes were like a suggestion box, except in this case, you get 10% of what you save as a reward for being a great citizen. Let's just get to get people involved again, because they're not involved. They're not involved.
Yeah, it would be. I think it would be a good idea.
Okay.
I don't think it would produce a lot of money-saving suggestions, because I don't think that there's actually that much inefficiency, contrary to popular belief.
$7,000 hammer on an atomic nuclear submarine, I think, would be one of those.
Really? Do you know what the specs are for that? In a lot of cases, a lot of these things that get lampooned, as soon as you start digging into it, you find out either it's total BS or there were actually really good reasons why you needed a $7,000 hammer to work around plutonium.
Hey, listen, I'm not,
But yeah, I mean, there are certainly inefficiencies in our government. I have absolutely no doubt about it. But I am equally in little doubt that that they are anywhere near as massive as a lot of people seem to think.
I mean, there's this guy, Ray Anderson, who's now dead, unfortunately. He ran a rug company down in Atlanta, and he had a suggestion box, and the employees benefited by financial reward for all the suggestions they made to make that country more carbon neutral.
I believe this is standard in Japanese manufacturing plants.
I would agree with you, but we don't seem to glom onto that very often here for some reason. Maybe we just say, well, it's good for them, but it probably isn't good for us, that sort of thing. Anyway, just worth a shot. I mean, high school students to be involved, and now you can make a couple of $1 million just by a great suggestion, in case you're right.
Yeah, there are some things like this. There are these contests to, come up with a solution for such and such. and you get money for it.
Right. Okay. But I mean, there's no,
But there's no general suggestion box on
exactly
with ideas for, yeah.
Or the reveal.
You would have to pay somebody to filter through all of the spam and stupidity that would get stuffed into that box.
Yeah, I know.
It may end up costing more than it generates.
We have we've had a couple of listener picks. We have two more. One's from Marshall. I don't have a question at the moment. Just the listener pick of the week. I don't know if you've seen it yet, but I came across this on Imgur. The caption says it all. It's a movie about DNA replication, an animation of DNA replication, which I've seen is really good. It's pretty neat. Anyways, been listening since the very beginning. I really appreciate all that you good doctors are doing for us lay people. Keep up the good work. Very beginning, wow. And Steve writes, here is a nice list of many of the flu vaccine myths all in one place for This Week in Vaccinations segment of TWiV. Steve, this is pretty cool. And it's, every myth about flu vaccine is debunked or just negated. And check that out. This Week in Vaccinations. Cool.
That's right.
Now, that's it. That's enough for today. And you can find this episode of TWiV at iTunes, twiv.tv. And as I always like to say, if you like what we do, go over to iTunes and leave some stars or a rating, which I bet you've never done, Dickson.
Absolutely right.
Why am I not surprised? That way we stay visible so that more people can find us. And do send your questions and comments to TWiV at twiv.tv. Kathy Spindler can be found at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This is fun.
Do you like Ann Arbor? I'm sorry. Do you like Garamond?
I like Garamond okay. For reading text, I like fonts that have serifs, and it looks like a nice one for that.
What is your favorite font?
I pretty much just use Straight Times for that, or Helvetica for sans serif fonts.
Okay. Alan Dove is at turbidplaque.com. You can also find him on Twitter. Thank you, Alan.
Always a pleasure.
Do you have a favorite font?
I guess I like Lucida for general use on the computer screen. Georgia is a pretty good one for a serif font.
Mm-hmm. I like Palatino. I have my CV in Palatino.
Oh, I used to like Palatino.
You fall out of loves with fonts, huh?
I do.
Because of my last name, I like Apple Chancery.
Just Apple Chancery. That figures a very flamboyant, flowery,
it is. No, it's an Apple
overdone font. Thank you, Dickson. Dickson can be found at...
now we have a new address, too.
We can't announce it yet. It's not out.
Fine,
Verticalfarm.com, Trichinella.org, and Medical Ecology. What is that, .com or .org?
It's a .org.
I can never remember.
It's an org.
Thank you, Dickson.
You're welcome.
And I'm Vincent Racaniello. You can find me at virology.ws. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.